Elon Musk's rocket company SpaceX aspires to colonize Mars with humans. Jeff Bezos, the founder of Amazon, envisions 1 trillion people living in space. But alongside Musk, the CEO of one private space company is taking a different approach to space exploration and hopes to play a role in the search for something unusual on Venus. Musk's primary focus has always been Mars, but he has recently focused on other planets, particularly Venus. As a result, several probes were sent to investigate the planet with the help of a private space company, and Elon Musk recently revealed what one of the probes discovered on Venus. What did the probe discover? Could there be life on the planet? Join us as we investigate why Elon Musk leaked what the probe discovered on Venus. If Earth has anything like a twin in the solar system, Venus is it. Venus's mass is about 0.81 that of Earth's. Its size is roughly the same. Its radius is 6,052 kilometers. Earth's is 6,378 kilometers. Because their masses and sizes are so comparable, that means that they have roughly the same density and thus the same composition. However, in other ways, they couldn't be more different. Venus has a surface temperature of nearly 482 degrees Celsius, 900 degrees Fahrenheit, and the pressure of its carbon dioxide atmosphere is 95 times that of Earth's atmosphere. Its clouds are sulfuric acid, and Venus's surface is an inhospitable wasteland. Much of the interest in Venus is concentrated on how two planets so similar could be so different. For instance, it takes Venus longer to rotate once on its axis than to complete one orbit of the Sun. That's 243 Earth days to rotate once, the longest rotation of any planet in the solar system, and only 224.7 Earth days to complete an orbit of the Sun, making a Venusian day longer than its year. Prior to Elon Musk's collaboration with the New Zealand-based private space enterprise, the former Soviet Union had been attempting to explore Venus. As a result, at the dawn of the space age, they developed and built many spacecrafts to research the Venusian atmosphere. This program was known as the Venera mission. The Soviet Union's Venera missions were launched between 1961 and 1983 to investigate Venus. However, only 13 of the 26 spacecraft launched reached the Venusian atmosphere, and 8 successfully landed down on the surface. Despite various failed attempts, the first probe to successfully land on Venus and send data back on its surface was Venera 7, with its landing in December 1970. The Venera 7 was built to penetrate the planet's atmosphere before deploying a parachute to help lessen its descent toward the surface. Unfortunately, the parachute ruptured and failed during the descent, causing the Venera 7 to fall freely for 29 minutes until crashing with a heavy thud on the Venusian plain. The Soviet Union probe appeared to stop sending signals as scientists tracked it. But when scientists later studied the recorded radio signals, it was discovered that the probe survived the descent and continued producing a feeble signal for another 23 minutes. Scientists assumed that the faint signal was caused by the spaceship landing on its side, which caused the antenna to stop pointing toward the Earth. The lander, despite the circumstances in which it found itself, measured a surface temperature of almost 900 degrees Fahrenheit, or to put it another way, almost the same as the temperature inside of a brick oven. Furthermore, as the spacecraft approached the Venusian surface, its pressure sensor failed, providing researchers with an estimated surface pressure of roughly 92 bars, a pressure that you could only experience on Earth if you were submerged in a half a mile of water. The Soviet Union never gave up on studying Venus, however, as Venera 9 and 10 landed on the planet's surface 5 years later and took a 180-degree panorama of the planet's surface. Ted Strick developed an artistic view of Venus by using images from the lander's panorama to portray what the planet would look like if an astronaut stood on its surface. The view was constructed by adjusting individual photographs in the panorama to portray the surface at a more natural angle, sampling each image at varied distances from the lander, and then utilizing image data to fill in any gaps left by this process. Although the objects in the photograph are natural, the arrangement is not. However, in order to see more of this planet's properties, the Soviet Union went on to develop other space probes, and the Venera 14 delivered exactly what they needed. In March 1982, the Soviet lander Venera 14 parachuted and air-braked its way through the thick Venusian atmosphere. It also photographed its surroundings, which included flat rocks, a featureless sky near Phoebe Reggio near Venus's equator, and a huge portion of empty landscape. The spacecraft's penetrometer is seen on the lower left as it takes scientific measurements, and the bright object on the right is part of an ejected lens cap. The solid Venera spacecraft operated for nearly an hour after enduring temperatures of 450 degrees Celsius and pressures 75 times that of Earth. Despite the fact that the data from the Venera 14 spacecraft was transmitted across the inner solar system about 40 years ago, the spacecraft's photographs and digital processing are still carried out today. A new analysis of infrared measurements acquired by the ESA's Venus Express spacecraft in orbit reveals that active volcanoes may exist on the planet. As Elon Musk and the New Zealand team continued with their mission, these assumptions regarding volcanoes on the planet proved to be correct. According to studies and observations of the Venusian atmosphere, Venus has the most volcanoes in the entire solar system. There are many more unidentified volcanoes among the 1,600 significant volcanoes found around the planet. A large portion of the world is covered in volcanic deposits that are around 200 million years old, and volcanic activity has played an important role in the planet's history. Scientists are still discussing whether there are still active volcanoes for a variety of reasons. But due to the planet's thick atmosphere, scientists had to rely on NASA's Magellan spacecraft's radar. In their attempt to learn more about the volcanic deposit, Soviet Union scientists developed a novel methodology that could aid in unraveling the secrets of Venus's volcanic activity. The method combines geologic maps of cooled lava flows from previous eruptions with radar data from the Magellan mission. It is based on radar emissivity measurements, which measure how the planet's surface interacts with and emits microwave radiation. Several sections of Venus's surface have shown different types of emittances that correspond to varied rock characteristics, revealing information about their genesis. Furthermore, new studies suggest that radar emissivity can be used to determine the degree of chemical weathering experienced by lava flows after they erupt and come into contact with the Venusian atmosphere. Because such weathering takes weeks or months, emissivity could aid in identifying new lava flows. Researchers used radar admittance measurements in conjunction with geologic mapping to compare 3 Venusian volcanoes, Mart Mons, Oza Mons, and Sapis Mons. Based on these observations, it appears that Mart Mons and a few of the lava flows on the planet are not as old as previously thought. Moving forward, the same approach could be applied to new Magellan data to explore Venus's volcanoes further. The methodology may also be required for future Venus missions, such as the ESA Vision mission and NASA's Venus Emissivity Radio Science INSAR Topography and Spectroscopy mission, which will provide higher resolution radar emissivity observations. More research, however, was undertaken under the direction of Elon Musk. Scientists and researchers used this methodology to examine a Venusian volcanic peak about 2.5 kilometers high and 200 kilometers broad. It can be found in a region of southern Venus that is known for its abundance of volcanoes in the highlands. Based on the findings of the research, it appears that there has been recent activity from the volcano. Previous study has revealed that the planet has less craters from cosmic impacts than one may expect, based on the number of craters observed on other rocky planets in the solar system. According to what scientists discovered with the Soviet Union probe, lava from these active volcanoes may be a factor in keeping Venus's surface clean. A greater understanding of Venus's volcanic activity could offer more light on the recent discovery of phosphine gas there, which some experts have strangely speculated may be linked to life on the hellish planet. The presence of phosphine in Venus's atmosphere could be linked to a recent volcanic event or one that is now taking place on the planet. Because of this, locating areas on Venus that contain potentially active volcanic material is essential. As a result of the discovery of phosphine gas, a privately funded mission to examine Venus's atmosphere was established. The purpose of the mission, which is being funded by Elon Musk, is to determine whether or not the planet indeed contains phosphine and whether or not it is capable of supporting life. Despite the fact that this was a privately sponsored mission, Musk was not the only one in charge of it. Researchers from the Massachusetts Institute of Technology are also leading the effort. The Breakthrough Foundation, in partnership with the Elon Musk Foundation and SpaceX, finances the initiative, with Jewish-American scientist Sarah Eager serving as principal investigator. The Venus Life Finder missions would be a series of experiments based on a probe sent to Venus to determine if the planet hosts life forms. This idea began when a team of scientists, led by Seeger, discovered phosphine gas in Venus's atmosphere. This sort of gas is not life because it is merely gas. However, phosphine is created by anaerobic bacteria that live in environments where there is a lack of oxygen. Making this discovery was a thrill to some, as it proved that life, although bacterial life, existed on another world. But given the planet's blazing heat and generally adverse conditions, how is this possible? It is common knowledge that the surface of Venus does not support life, but the cloud layer, approximately 50 kilometers above the surface, does. It is similar to the lower atmosphere of Earth's and may hypothetically host microbial life. However, there is still some skepticism about the idea, as rechecking the data has led some scientists to believe that the theory was misunderstood and that the molecules could be sulfur dioxide, a gas that is abundant in the Venusian clouds. In science, researchers must be certain of a phenomenon before acting on it. As a result, sending a probe to collect samples from the cloud deck was necessary. The expedition cannot be carried out on an interstellar scale, but in the case of Venus, which is closer to Earth, the mission appears more promising. Their first mission is scheduled to launch this year on an electron rocket developed by the California-based Rocket Lab in partnership with Elon Musk's private space agency. This rocket would launch the probe on a 5-month journey for just 3 minutes through the clouds. To achieve the best results, the probe would be outfitted with a specially developed laser instrument that would identify the complex chemistry in the clouds. And if impurities or fluorescence are discovered, it would indicate that there is more to Venus's atmosphere than we now know. What are your thoughts on the mission to study Venus's atmosphere? Share your opinions in the comments section below.